not going to do all four operations here, just one of them. F of x is 2x plus 1 over x minus 3. And g of x is x minus 5 over x plus 2. What's f plus g of x? 2x plus 1 over x minus 3 plus x minus 5 over x plus 2. How do we add two fractions together? Common denominator. What's the least common denominator? X minus 3 times x plus 2. So first fraction I need to multiply by x plus 2 over x plus 2. And second fraction I need to multiply by x minus 3 over x minus 3. So for the first fraction, top, we get 2x squared plus 5x plus 2. Second fraction, top, we get x squared minus 8x plus 15. Add the two fractions together, what do we get in the numerator? 3x squared minus 3x plus 7. And there's no need to multiply the bottom. What's the domain?
Can equal 3 or negative 2?
X cannot equal 3 or negative 2. We can't use anything that makes the denominators. So these first four operations, you guys should have done quite a bit of these in your mathematical careers. It's the fifth operation that's going to take us more time. Position. Given two functions, f and g, the composition function written with this notation. Please don't come in Wednesday and ask me to do one of those fog problems. It's not the letter O, it's just a little circle that represents that operation. And this is red, F composed with G. Okay. Think of this function like this. So here's a function machine. And we're going to put some value of x into this function machine. And what pops out is f. Well, for composition with a function machine, it looks like this. Start with some value of x, plug it into a function g, out pops g of x. Take that value immediately and plug it into a function f, and out pops f of g. This is one way we can think of composition. Composition is just chaining together two or more functions. Do one, take the answer, put it into another function. One way we can think of composition is a chain of functions. Let me try this with variables. I want to try this with just numbers. Let's do f of x is x squared, g of x minus 3. Find f composed with g of 5 and g composed with f of 7. So, by our definition, f composed with g of x is f of g of x. So this is f of g of 5. Now, order of operations, what do you do first? There's no distribution here. This is not multiplication. This is a function. What do you do first? You do what's inside the parentheses first. What's g of 5? The 5 minus 3 is 2. Take that value and immediately plug it into function f. What's f of 2? Or take 2, plug it into the function. G composed with f of 7 is g of f of 7. Order of operations, what do we do first? What's inside the parentheses? What's f of 7? 49. So take 7 and plug it into function f. It says take that result and plug it into function g. What's g of 49? 46. Same two functions, let's do f composed with g of 3 and g composed with f. F composed with g of 3 is f of g of 3. What do we do first? What do we do first? Inside the parentheses. What's g of 3? 0. Take that value that we got and now plug it into function f. What's f of 0? 0. G composed with f of 3 is g of f of 3. What do we do first? Inside parentheses. What's f of 3? 9. And then what's g of 9?
6.
6. What's the first thing you notice about those two answers? They are not the same. F composed with g of 3 is not the same thing as g composed with f of 3. 99% of the time, when we compose two functions together, the order is really important. You're going to get two completely different answers. That other 1% of the time, one of those is something we're going to talk about Wednesday. A case where you do get the same answer. But most of the time, we don't get the same answers. Let's get those same functions up there. Find f composed with f of -2. And then find g composed with g of 4. Do is f of -2. We do what's inside the parentheses first. What's f of -2? 4. And then what's f of 4?
15.
G composed with G of 4 is G of 4. We do what's inside the parentheses first. What's G of 4? 1. And then what's G of 1?
-2.
Negative 2. The moral of the story is you can compose a function with itself. They can be the same function. As long as I have those functions up there, let's work with those to start. Those are two nice, easy ones. Right, now I want to look at compositions not involving numbers, but just involving x. So I want to find f composed with g of x and g composed with f. So f composed with g of x is f of g of x. Order of operations, what do we do first?
Plug it into G.
What's inside the parentheses? G of x. What's g of x? X minus 3. Now, how do we find f of x minus 3? So this is very similar to that problem 1E that was on the quiz. How do you find f of x minus 3? Go to the function f, wherever you have x, plug in x minus 3. X minus 3 squared. X minus 3 squared.
Thank you.
Squared. Minus 6x. Plus 9. G composed with f. By our definition is g of f of x. What do we do first?
X squared.
What's inside the parentheses? So what's f of x? X squared. Yeah. What's g of x squared? X squared minus 3. Once again, what's the first thing you notice about those two? They are not the same thing. The order does make a difference here, so the order is important. Let's do one last thing with this and then we'll take our break. What's the domain of function f? All real numbers. What's the domain of function g?
-3.
All real numbers. What's the domain of function f composed with g? All real numbers. And what's the domain of function g composed with f? All real numbers. If your two original functions were polynomial functions and we didn't have any glitches in them, you're not going to have any problems with domains.
How did you get x squared minus 3?
All right, so this says go to the function g, wherever you see x, plug in x squared. Here's the function g, wherever you see x, plug in x squared. The place that we're going to run into problems with domains is when we start looking at fractional functions. So that's something that we'll do after the break. We're going to do several more of these tonight. Let's come back